So we're moving on to trigonometry, and the first exercise in chapter 11 is about angles of any magnitude. Now we have seen this before. So what I've got here is the unit circle. So this is actually 1 here. So there's 1 up there, so this is -1, and this is -1, that's the unit circle. And if you look at this angle in here, theta, over here you bet 0 degrees. Going round, you get up to 90 degrees, 180 degrees, 270 degrees down here, and then you'd be back to 360 degrees over here. And in fact, you could keep going round and round and round. So 720 degrees would be round twice. You can also go back in the other direction, which we'll be looking at during this exercise as well. So we know that if we look at this triangle, if this is the point on the circle xy, then the length of that is 1. This distance is just the x coordinate, so that length is x, and this distance is just the y coordinate. Now this is a bit of revision, we've seen this before. So just over here, what we can see here is that sine of theta is opposite over hypotenuse, so that is equal to y. Cos of theta is adjacent over hypotenuse, so that's equal to x. And tan theta, of course, is the opposite over the adjacent, which is the y over the x. And we'll see in the next exercise, we'll revise how that is also equal to sine theta over cos theta as well. Okay, now let's look at what happens in the second quadrant. So what I'm going to do here is I'm going to draw this exact same triangle over here in this quadrant. So here's my line, and this of course would have coordinates x, y as well. Now this angle here, because this is theta in here, this angle would be 180 minus theta. I'm actually going to write that up near this point here. So that's at 180 minus theta, this line here. And what we want to know is the trig ratios of this angle. Now we can use what we've learnt down here, that sine theta is actually equal to the y coordinate and cos theta is equal to the x coordinate. So we're just extending these rules into this quadrant. So let's look at what those x and y coordinates are. So if I go straight down here, now those two triangles are exactly the same. They're the same size, they're just drawn in a different place. So this y here is equal to that y there. This x here, well, in that direction it's going to be negative x because we've gone into the negative quadrant. So what we find is that if we take sine of this angle, it's still going to be that y coordinate. So sine of that 180 minus theta, this angle, is equal to y, and that's just equal to sine theta, which is pretty cool. So sine of 180 minus theta is actually just straight equal to sine theta. Let's look at the cosine. So the cosine is negative x over 1. That's still just 1. So the cosine of this angle is negative x over 1. We just look at this triangle because we're looking at this coordinate. And that realistically, actually, that's negative x there. So the cosine of 180 minus theta is the negative of x. And that, from here, is just equal to negative cos theta, which is quite useful. And tan, well, we know tan is equal to sine over cos down here. So we can see right there that that's y over negative x, which we can also see back up here that it's the opposite over the adjacent, so that's the y over the negative x. And now that's equal to the negative of this one. So it's equal to negative tan theta. So you can see here the sine came out positive, but the cos and the tan came out negative. So in the first quadrant, they were all positive. All three of them were positive. We've talked about this before. In the second one, only sine is positive. Now, let's look at the third quadrant. So let's draw that exact same triangle again. So we're going to come down with the exact same negative x coordinate. And that's going to go down the same distance. This is just exactly the same triangle drawn in this quadrant. So we now need to look at this angle, and that's this angle here is theta. So this whole angle to here is going to be 180 plus theta. Okay, the whole angle. And the coordinates at that point, the x is negative, so negative x, and the y is also negative, so it's also the negative of the y, of this xy, compared to these ones up here. So let's look at sine and cos and tan of that one. So I'm looking over here, so sine of 180 on theta, we're looking at this angle, so we're looking at this line, and we know that sine is equal to the y coordinate, which in this case is a negative. So that is equal to the negative y over 1, okay, which is the negative y over 1. And so that's equal to the negative of sine theta. All of these we compare back to the triangle in our first quadrant. So cos of 180 plus theta is the negative x over 1. The radius is always positive, by the way. So negative x over 1, so that's the negative of x, which is equal to the negative cos theta. And tan is, of course, those two divided, so negative y over negative x, and that becomes positive, so it's actually just equal to tan theta. So we found some nice rules there. Sine was negative, cos was negative, tan is positive. Let's just write a T down here for tan being positive. And then move on to our fourth quadrant. So let's draw that exact same triangle again in the fourth quadrant. So exact same triangle, so this is theta, but now we're actually considering this whole angle all the way around to there. And because all the way around is 360, this is going to be at 360 minus theta. Okay, so 330, for example, it'd be 30 degrees away. And the coordinates there, the x is positive again, the y is negative. Now we can compare with our rules over here, or we can just look at this triangle, that the sine of 360 minus theta, the sine for this line, is the opposite over the hypotenuse, which is the negative y over 1, which is the negative of sine theta. It's the negative of this one up here. For cosine at this point, it's the adjacent over the hypotenuse, so it's positive x. And that one up here we can see is just equal to cos theta. And tan of this point here is again equal to the opposite over the adjacent, so the negative y over x, which is the negative of tan theta if you compare with this one up here. So those are some great rules. You do not need to memorize any of that. It's all just about working it out each time, and I'll show you that in some examples. And of course in this quadrant we saw that cos was the only positive one. So we can remember ASTC, or all stations to central, to know which one's positive. They're all positive here. Sine is positive here, the others are negative. Tan is positive here, cosine is positive here. If they're not mentioned, then they're negative. So example 1 is about finding exact values. Now anytime you see that word exact values, you need to think about those exact value triangles that are on our reference sheet. So one of them has 45 degree angles. Remember, it's a unit square cut in half. So this distance is 1 because a unit square has a side of 1. This distance is 1, right angle there. By Pythagoras, this side is equal to the square root of 2. And this is an equilateral triangle cut in half. It did go down here, but not anymore. So this angle is 60 because we know the angles in an equilateral triangle are 60 degrees. This one has been cut in half, so that one's 30. The equilateral triangle has a side length of 2. So this is 2. This side has been cut in half, so it's 1. And by Pythagoras, this height is the square root of 3. And remember, those are on your reference sheet. But anytime you're asked for exact values with trigonometry, that's where you're looking. Those are the triangles you're looking at. Now, when these angles are no longer acute angles, that's when you need to start thinking about your unit circle. So when it says find the exact value of 330, we need to work out where 330 is. So I'm going to start with a little sketch. So the first step is working out which quadrant we're in. Now, remember 0, 90, 180, 270, and then back to 360 over here. So 330 is down in this quadrant. So I just tend to draw a line down there and say that's 330 degrees. And then what I do is I find the angle to the x-axis. I can't emphasize that enough. It's the x-axis, not the y-axis. So we need to find this angle here. Okay, and that angle is going to be 360 minus 330, which gives us 30 degrees. In our explanation before, we would have actually written it like this because the theta is the 30. So we would have written it that way, but the 30 degrees is this angle in here, and that's the important thing. This angle is 30 degrees. So that's the first thing I think about. And then I think, okay, is my answer going to be positive or negative? So I do all stations to central. Actually, these two things, it doesn't matter which order you do it in. Now, cos is positive down here, which means sine is going to be negative. Sine will be negative, and it's going to be the negative sine. We're just comparing it with the exact same triangle up here, 30 degrees. Okay, so the negative because it's this quadrant, and the 30 degrees because of that. Now, from this triangle, we can see that the sine of 30 is 1 over 2, opposite over hypotenuse. So that equals the negative sine 30, and sine 30 is half. So there's our answer. Let's do a second example of that. So on this one, we're asked to find tan of 225 degrees. So let's draw our little quadrants. This time I'm going to do all stations to central first. And we're going to look at which quadrant we're in. Now 225 is between here and here. So it's down this way. There's our 225. And remember, the next step is to find the angle to the x-axis. So we want this angle here. So essentially we want to subtract 180 because all the way around there is 225. And there's our 180. So our angle in here is going to be 225 minus that 180, which is 45 degrees. So first of all, tan is positive there. So the answer is going to be positive here, and it's going to be equal to that same triangle up here with a 45-degree angle. Now let's look at our exact ratio triangle. So this time we're looking at this triangle with 45. You can use either one. So tan of 45 is opposite over adjacent, so the answer is 1. So question 2 asks us to simplify cos of 180 plus x, where x is acute. So 180 plus x, just like up here, puts us into this quadrant, into the third quadrant. Okay, so it's quadrant 3. So we need our all stations to central. All stations to central. And what we can see is that it's going to be negative. So that's going to be negative cos x, because this angle in here will be x, 180 plus x. So the answer there is just negative cos x. Okay, a few more exact values to find. The first one is the exact value of cos of negative 30 degrees. So when you get negatives, essentially we're just going backwards around the unit circle. So negative 30 degrees is 30 degrees that way. But the triangle is still the same size. All stations to central, the answer is going to be positive because cos is positive in this quadrant. We've gone backwards 30 degrees into this quadrant. So the answer is going to be the same as if I had this exact same triangle drawn up here. So just equal to cos 30. Now cos 30 from our exact value triangles here's 30, so root 3 over 2, adjacent over hypotenuse. So the answer down there is just root 3 on 2. Okay, tan of 750 degrees. Now, when you get a big angle like this one, you've got to think, well, I've gone round more than once. So if I go round once, I get to 360 degrees. If I go round a second time, that's 2 lots of 360, so that's 720. So this angle 750 is a bit more than 720, so it's actually going to be back here in the first quadrant again. And it's going to be 30 degrees into the quadrant to make a total of 750. 750 minus 720 gives us that 30 degrees. They're all positive in this quadrant, so that's positive tan of 30. It's the exact same answer as we got before. Now, tan of 30 from our exact value triangles, here's our 30 degrees. Tan is opposite over adjacent, so 1 on root 3 is the answer there. So 1 over the square root of 3. Okay, so here's a similar one, sine of 990. So often what I do for this type of question is I put the 990 in my calculator and I start subtracting 360. So I've put 990, I've pressed equals, now I'm just going to go minus, which will give me answer minus 360. And I'm at 630, it's still more than 360, so I press equals a second time. I'm down to 270. Now that's under 360, so I want to stop there and I want to work out where that is. I could actually go one more if I wanted to and call it negative 90. So what we find with this one is I've either gone round to 270, I went round a couple of times and then to 270, or backwards to 90. But what I find is I'm actually right here on my axis. Now that's much harder to draw a little triangle for, so there are a couple of ways you can do that. Once we learn about the sine curve, which we're going to learn about later, we can use that. So in this one, this is 360 degrees, this is 180 here, 270 is here, and that answer is negative 1. So that's one way we can do it, and we'll look at that in more detail later. Another way to do it is to remember that sine x is sine theta is equal to the y coordinate. Now the y coordinate here, because this is the unit circle, is actually negative 1. So there's our answer, negative 1, just like I said here. The other thing about any time you end up on an axis is you're actually always going to get a really nice number if you just put it straight in your calculator. So if I just go sine 990 in my calculator, you can see that I do get negative 1. So anytime it is on an axis, you can actually just use your calculator also.